I want to introduce another way of solving system of equations using matrices. Here's an example that you may see in electrical engineering. Typically when you use Kirchhoff's law, you get equations like this, where I1 and I2 are currents measured in amperes, 12 is some voltage source, it's in volts, 700 and 300 are coefficients, and these are resistances of each resistors. Anyways, when you have a system of equations like this, how do you solve it? You first write it into AX equal to B format, because in this matrix equation you have a very easy way of solving it. It's just A inverse B. A inverse B is the solution to the AX equal to B, and you can calculate this using your calculator. Now, I already explained this in the previous video, but let me give you a quick demonstration. I already have the matrices ready. Here's the matrix A, 700, negative 300, 100, and negative 400. And matrix B, I'll show you matrix B, it's 12 and 0. Once you have this matrix A and B, you can do A inverse B, A inverse B, and it will give you these numbers, 0.0192 and 0.0048. And of course you should write your answer in scientific notation like this, including the units in amperes. Now, what is the second method? The second method saves you a little bit of time, especially when you have lots of variables, unknowns. Let's say if you have I1, I2, and then another I3, I4. Then rather than working with two matrices, the second method uses just a single matrix made out of the two. So you have this matrix giving you the first part of the matrix, this matrix B giving you the second part of the matrix, and you have this single matrix of 2 rows and 3 columns. So it's a 2 by 3 matrix. Now what do you do with this single matrix? You do something called Row Reduced Echelon Form, by the way, which uses something called Gauss elimination. It's a totally different theory than the previous one, A inverse B, that I explained, so it should be a topic for another video. However, the method itself can really, you don't really have to understand the method. You can just calculate with your calculator, and you just have to know how to interpret your result. Okay, so what do? You first plug in this single matrix. Let's modify the matrix A because it already has some of the coefficients there. It's not a 2 by 2 matrix, it's a 2 by 3 matrix, and that adds an extra column at the end, and we just have to put 12 and 0 there. Okay, so we have that. Once you have this matrix as matrix A, then you just have to calculate row reduced echelon form of A. And the way you do it is press matrix, then go to math, and you scroll down, and at some point at the bottom you'll see row reduced echelon form, rref. That's the one that you want to hit enter. So rref of matrix A, let's see what we get. The result is a 2 by 3 matrix where we see these numbers which we recognize from the previous solution. Remember, we had the solution 0.0192, and we again have 0.0192. Now, if you know how to interpret this, you'll clearly see why this is equivalent to the previous answer. So, to interpret this, you have to remember that the 2 by 3 matrix was composed with matrix A and matrix B. So this part is matrix A and matrix B, and what we are going to do with the result of the row reduced echelon form, we're going to do the reverse process of what we did before. So this is matrix A, that's matrix B, and we are going to write it as AX equal to B. Now once you do that, you recognize this matrix. This I explained in one of the previous videos. I explained that this is something called an identity matrix, because if you multiply this matrix to the other matrix, you just get the same exact thing. That's why it's called identity matrix. And you can actually do the matrix multiplication to get to find out that the left side turns into just I1 and I2. Just do this: 1, 0 times I1, I2. It's the rule for matrix multiplication is across down. So you do across down, 1 times I1, 0 times I2. You add them together, you get I1. You do the same thing over here: 0 times I1, 1 times I2. Adding them together, you get I2. So the result that you get from row reduced echelon form is exactly same as what we got before. And the advantage is that you get to use just a single matrix rather than two matrices. Now there's another reason why you want to use row reduced echelon form rather than A inverse B. Let me try to explain using the second example, which is almost same as the first one. The only difference is this number 75 and 16. So let's get the matrix ready, edit. So instead of having that 700 there, we're going to put 75. And then over here we get 16. Now, before I show you the result of the row reduced echelon form, I'll just mention that if you try to solve this by using AX equal to B, you wouldn't get an answer. I think you should try it on your own to see that that's the case. So let's do the row reduced echelon form. Again, A inverse B does not give you any answer. What does the row reduced echelon form give? Let's see, math, scroll down, row reduced echelon form, matrix A, enter. And you get this result. What is this? In order to understand the result of the row reduced echelon form, you have to again split this into A and then B, so it's AX equal to B type. And then if you do the matrix multiplication across down, the first row gives you 1 times I1 times negative 4 times I2 equals to 0.16. The second row gives you 0 times I1 plus 0 times I2 equal to 0. You will see that this second equation is meaningless because the left side is 0, so it's a trivial equation. It just says that 0 is equal to 0. And the first equation is I1 minus 4I2 equal to 0.16. So this is what I mean not all systems have solutions, but if it does not have any solutions, then the row reduced echelon form tries its best to come up with a single or a few reduced set of solutions so that you can use it. If you're wondering why this system does not have a solution, let me elaborate on that a little bit. Okay, although you have two equations with two unknowns, I1 and I2, it's really a single equation. Why do I say that? Well, to see that, take this equation and divide by 4. 100 divided by 4 is 25. 400 divided by 4 is 100. 16 divided by 4 is 4. So this equation is equivalent to this equation because all I did was divide by 4. Then try multiplying by 3. 3 times 25 is 75. 3 times 100 is 300. 3 times 4 is 12. What did we get? That's the first equation. So in other words, the second equation is exactly the same as the first equation. I mean, when you see this system, you think you have two different equations, but it's just a single equation. That's why this system failed to give you a definite answer. That's why the A inverse B wouldn't give you an answer. However, if you use row reduced echelon form, it will try to get the best result you can extract from there. Thank you for watching this video.